Welcome guys. In this video our focus will be on science paper 2 for the 2024 for the GCE, and we're going to look at this section B of this paper. So we have the first question: a box of chemicals in a laboratory has the following symbol attached to it. Right, so from the symbol and from the diagram we can see that we have the flames of fire. So since it's based on flames of fire, question A, Roman number 1, depends on the nature of flames. Describe the nature of chemicals in the box related to the symbol. So we can see that these chemicals are highly flammable. Okay, so we can now move on to Roman number 2. Write a laboratory rule that is observed when handling chemicals in this box. So we can say we keep away any liquid or substance that is highly flammable. Okay, so we can now move on to question number B. So question number B is talking about when a bottle of ammonia is opened, within a few minutes its smell is spread throughout the laboratory. So question number Roman number 1, name the process responsible for the evenly spreading of the smell of ammonia. So if we look at evenly, we are looking at where we have the equal smell. So the process responsible for evenly spreading is known as diffusion, because we know that ammonia is a gas. So we are looking at the movement of particles from one position to another position to specify from the region of high concentration to a region of lower concentration until we have evenly distribution. Describe the process responsible for the even spreading of the smell of ammonia solution. So we'll say the ammonia particle moved from the region of high concentration higher concentration to a region of lower concentration. So this happens until the whole room has the same smell. So we can now move on to Roman number 3. Relate the evidence with which the process named in B1 provides to the kinetic theory of matter. So we can say the particles are free to move, because we know that we are looking at the movement of particles. So the particles are free to move, and kinetic theory of matter tells us how particles are always in random motion. So that is the answer. So let's move on to question number 2. The following diagram shows a piece of apparatus used in the laboratory. We are given this apparatus, then we have the stopper, then we have the tap here. Question A1, name the piece of apparatus shown in the diagram. So this is a separating funnel. Identify one property of a mixture separated by the piece of apparatus named in A. So one property is that they are immiscible, which simply means that the liquids that we can separate using this cannot mix, so we are dealing with immiscible liquids. And another property is having a different density. So because they have different density, the two liquids cannot mix. For example, water and oil have different densities, and if you are trying to mix them, they can't mix completely. Roman number 2 suggests the names of two liquids that can be separated by the piece of apparatus shown in the diagram. So I'm going to say water and oil, such as, let's say, cooking oil. So in terms of mixing, water is denser than oil, so therefore water will be on the bottom part while oil will float on water. Question C suggests two precautions that need to be taken to separate the mixture B2. So the first precaution is we need to be careful when opening and closing the tap. So be careful when opening and closing of the tap. Then the second one is where the observer is. So in observing, you need to make sure that you are able to see the two different layers. So observe at a good angle. Make sure you are able to see the two distinct layers. Move on to question number 3. So question number 3, the following diagram shows the electron configuration of the ion of an element M. So we can see the charge. So the charge is positive. So whenever you see a positive charge, it simply means that this element lost electrons to gain stability. Therefore, 2 electrons were given out to become stable. And since 2 electrons were given out, this is an example of a metal. So for Roman number 1, we are told to draw the atomic structure. So the atomic structure is before the electrons were lost. This is an ionic structure. So to draw the atomic structure, and also we are told to write the electronic configuration. So how can we write the atomic structure? So we are going to write the atomic structure based on the ionic structure. So we have the first shell. This shell has 2 electrons, so I put 2 electrons. The second shell has 8 electrons. Then the third shell has also 8 electrons. Now what are we supposed to do? Are we going to add the fourth shell or what? Yes, we are going to add the fourth shell, the shell that had the 2 electrons that were given out. So here you just have to put the outermost shell where the 2 electrons that were given out were before the giving out. So this is how the atomic structure. So remember, the atomic structure is where the losing or gaining is not yet done. Then in terms of configuration, so start with the first shell, 2 electrons. You write 2 electrons. The second shell is 8 electrons. Third shell, 8 electrons. Then the fourth shell is 2 electrons, those that were given out. So if it was a minus, it simply means that the element gained. So if it was a minus, you need to remove 2 electrons from the outermost shell. Then Roman number 2, give the name, group, and period of the element M. So the name is calcium. If you look at calcium, calcium has 20 electrons. Group, you have to count the number of electrons in the outermost shell. So we have 2 electrons in the outermost shell, therefore this is in group 2. Period, count the number of shells. So we have 4 shells, so this is in period 4. Then we move on to question B. Question B, compare the reactivity of an atom of M and an ion of M. So an atom is before the giving is done, then an ion is when the element is now stable. So you know that an ion is stable, so it can't react because it's stable. So this atom of M is more reactive than the ion of M. So say an atom of M is more reactive than the ion of M. So that's our comparison. So let's go to question number 4. So question number 4, salts are substances that have many methods of preparation. Iron 2 chloride can be prepared by reacting substance X and dilute hydrochloric acid. So we are dealing with a reaction between a metal and an acid, of which we know that hydrogen and salt must be formed. Which reactant should be in excess? So whenever we are dealing with a reaction between a metal and an acid, between the metal and an acid, which one must be in excess? So the metal should always be in excess. Why? Because we want to make sure that all the acids are used up. So it's easy to get rid of the excess metal compared to the excess acid. So that's the reason. Or you can just master this point as whenever you're dealing with a reaction between a metal and an acid, make sure that the metal is in excess so that all the acids are used up. Then the remaining excess metal can be just filtered to remain with the salt. So which reactant? So say substance X. Then why should the named reactant in A1 be in excess? So say to make sure that all the acids are used up. So that's the reason why we have to make sure of that. B1 suggests a suitable reactant as substance X. So that should be ion. Write a balanced chemical equation for the reaction between substance X suggested in B1 and dilute. So we'll say ion, symbol Fe, solid, plus hydrochloric acid is HCl equals. So hydrogen will be displaced. So we're dealing with a single displacement. Now we know that the ion has the valence of 2. Chloride has a valence of 1. So we're going to put 2 on the chloride plus hydrogen gas, the atomic. So to balance, I'm just going to put 2 in front of HCl. As we can see, our equation is now balanced. So we move on now to question number 5. The question reads 10.5 grams of sodium hydroxide was reacted with dilute sulfuric acid according to the equation. So we have sodium hydroxide is a base plus sulfuric acid. So the first question is, we are supposed to balance this equation. So first we need to start with sodium. How many atoms of sodium are on the product side and on the reactant side? So from the product side, we can see that we have 2 atoms of sodium here, 1, which tells us that we need to put 2 in front of sodium hydroxide. So 2 atoms of sodium, 2 atoms of sodium. We can see a 2 here. Then this 2 is also affecting the hydroxide. So in total, we have 2 from the sodium hydroxide and 2 from the sulfuric acid, giving us 4. Then here we have, so to balance, we can check that this 2 is also affecting the hydrogen. So 2 atoms of hydrogen from the sodium hydroxide and 2 atoms of hydrogen from sulfuric acid. In total, we have 4 atoms of hydrogen on the reactants. So we are going to put 2 in front of water so that we have 4 atoms. So at this point, our equation is now balanced. B1, use the balanced chemical equation to calculate the mass of sodium sulfate formed. So there are different ways in which you can find it. You can use mole to mole, then use the moles to find mass, or you can use mass to mass. Now what I'm going to do is I'm going to use mass to mass. So how do you use mass to mass? Focus on the elements, the substances, number 1 whose mass is given, and the second one whose mass you are solving for. So the one mass is given in sodium hydroxide. That's the one I'm going to write here. So I'm going to start with finding the mixture for sodium hydroxide. So from the sodium hydroxide, we have 1 atom of sodium. So say sodium times 1 plus 1 atom of oxygen times 1 plus 1 atom of hydrogen. So the mass number for sodium is 23 times 1 plus 16 times 1 plus 1 times 1. 23 times 1 is 23 plus 16 plus 1, giving us the total of 40. So 40 is the mass for 1 compound of sodium hydroxide. Now remember, there is a 2. So you need to make sure that you put the mole ratios into consideration as long as you are dealing with mass to mass. So 2 times 40 will give us 80. Then number 2, we are going to find the mixture for sodium sulfate. So you say Na2SO4. So we have mixture is equal to sodium times 2 plus sulfur times 1 plus oxygen times 4. So sodium is 23 times 1 plus sulfur so 32 times 1 plus 16 times 4. So 23 times 1 is 23 plus 32 plus 16 by 4 is 64. So 64 plus 23, 32 plus 23. So according to my calculations, I'm getting 119. Then after this is done, I'm going to say sodium hydroxide to sodium sulfate. Then upon reaching here, the mixture for sodium hydroxide is 80. What is the mass? Mass for sodium hydroxide is 10.5. So I'm going to write 10.5 on the left side since that's where our sodium hydroxide is. Then the mixture for sodium sulfate is 119. Then here I'm going to put X because our target is to solve for mass of sodium sulfate. You cross multiply, so 80 times X is equal to 119 times 10.5. So I'm getting 1249.5 over 80 over 80. So X is equal to, X is equal to 15.6 grams. So this is our final answer. Right, so Roman number 2, what type of reaction is involved in the equation? So we know that we are dealing with sodium hydroxide. This is a base. Then sulfuric acid is an acid. So the reaction between a strong base and a strong acid is known as neutralization. So this will give us neutral products, which is, I know some people you may also call it acid-base reaction. Okay, so now let's go to question number 6. So question number 6, an element A is in group 1 of the periodic table. So group 1 are metals. Another element N is in group 7, so these are non-metals. So at least we've identified the first thing. So metals lose electrons to become stable, non-metals gain electrons to become stable, so they are electronegative. Write one property of the compound formed when element N react with N. So when a metal reacts with a non-metal, will give us an ionic compound. So one property of ionic compound is that they conduct electricity when in molten. So conduct electricity. When in molten state. Or if you want, we can say they have high melting and boiling point. That's also an answer. What type of bonding exists in the compound formed? So we know it's ionic bonding. So ionic bonding exists between the cation and an ion, so between a positive ion and a negative ion. Therefore, they are very strong due to the opposite charges. So how does the reactivity of elements in group 1 differ from that of elements in group 7? So in group 1, for example, if we take lithium, sodium, potassium, so their reactivity increases as you go down the group. But for group 7, we have fluorine, chlorine, we have bromine, iodine. Their reactivity increases as you go up. So that's the difference. So say elements, so say reactivity of elements in group 1. I'm just going to write G1 increases as you go up. As you go up the group, wow. In group 7 increases, oh sorry, not go up, go down here. Wow, in group 7 increases as you go up. We can now go to question number 7. Metallic bonding accounts for most of the physical properties of metals. With reference to metallic bonding, explain why most metals have high melting point. So for a metal to melt, we need to make sure that we break the forces between the positive and the negative. So since the force of attraction between the two opposite charges is strong, thus the high melting point, which simply means we need a lot of energy to break those bonds. So we'll say because the force of attraction, between the positive and negative is strong. So that's the reason why it has, or they have, high melting point. So because of the forces are very strong. Then we have question B. Draw a diagram to show metallic bonding in zinc metal. So whenever you want to show metallic bonding, you can just do it like this. So you write the positive So remember, these are known as cations. Then in between we have the minus. So the minus, we call these as the sea of electrons. Or if you want, you can draw it like this. Since it's a zinc, you write zinc plus 2, another zinc plus 2, another zinc plus 2. Then in between we put the minus. It's still the same. A learner carried out the following experiment. In experiment 1, 5 grams of powdered zinc, and in experiment 2, 5 grams of granules of zinc were each reacted with equal volumes of dilute hydrochloric acid, both of the same concentration, for 15 seconds. So the only difference was the first experiment they used a powdered. So powdered simply means that the sizes are very small, or their surface area are very small. Then for granules, we are looking at bigger particles, in which experiment was a large volume of hydrogen produced. So we are expecting to have where the reaction was fast. So the reaction was fast in a powdered. So we'll say in experiment 1. In experiment 1, because powdered react faster than granules, because we know that for reactants to react, the particles must collide. So for example, if you look at, let's say this is reactant A, then this is reactant B. So it's easy for the smaller particle to move to collide with another particle compared with this larger particle. So question now 2. What would be the effect of reducing the temperature of the acid in the reaction? So the reduction in temperature results in a low kinetic energy. Of the particle. So as long as the kinetic energy reduces, then we can now conclude by saying the reaction will slow down. So temperature is one of the factors that can make the reaction to go fast or slow. So the increase in temperature results in the speeding of the reaction and vice versa. We move on to question number 8. The following diagram shows the laboratory preparation of a gas and its collection. So we have the dilute hydrochloric acid and granules of metal Y. Then in question A, identify Roman number 1 error in the setup in the diagram shown. So you need to be extra careful as you are studying. So make sure you also put the diagrams into consideration, because if you look at this diagram, if you haven't studied carefully, you may not see the error, but the error is there. So let me look at this part here. We call this one as Thisto funnel. So if you look at the way it should be, this Thisto funnel must be dipped. It has to make sure that it enters into the granules of whatever reacting. So the excuse me, the error was the Thisto funnel was not dipped. Was not dipped into the reacting material. Then gas X, since this is metal, so a reaction between metal plus any acid, we are going to have salt plus hydrogen. So the gas that we are dealing with is hydrogen. So gas X is hydrogen. Then predict what will be observed if metal Y is replaced with copper. So no reaction. So no reaction because copper does not react with acid. Now with reference to air pollution, compare the use of ethanol and diesel. So to compare is like we are trying to come up with the similarity. So we say they all burn in air, producing or giving us carbon dioxide. Carbon dioxide, which may pollute the air, so which may cause global warming. That's a comparison. Now the last question is about organic chemistry, and I have a topic on this video where I have just looked at organic chemistry to make it simple for you guys. The following table shows some of the fractions of hydrocarbons obtained from fractional distillation of crude oil. Fractions A, B, C, D, boiling range per degree Celsius. Which fraction contains the longest chain? Give a reason for your answer. So this question, the way it was phrased, it was about how can you determine how long a chain is depending on the boiling point. So the longest chain must have the highest boiling range per degree Celsius. So we'll say fraction D. Reason, because it has the largest boiling point. So the greater the boiling point, the longer the chain. Okay, or it has more of that. So we can now move on to question number B. So decant C10H22 can be cracked to produce hexane and one other hydrocarbon T. So now the answering of this question didn't depend about the formula that you know about, maybe alkanes and alkenes. So this one, you need to make sure that you understand cracking. So cracking is where you have a longer chain and you break it into smaller chains. Now the key point about this is that make sure that the number of carbon atoms and hydrogen atoms on the reactant side, on the left part, balances with the number of carbon and hydrogen on the product side. So what do we mean? We need to do this. So we have C10. I'm going to consider this one as my reactant. Breaks to produce the first one is C6H14. Now since we are told only 2 products were produced, so what are we supposed to do? I'm going to write carbon. So how many carbons are we going to expect in the other product? You just have to look at the number of carbons on the left side. So we have 10, here we have 6. So how many are remaining to make it 10 is 4. Or to simplify things, you just say 10 minus 6, then here we are going to have 4. So we are going to do the same. So hydrogen, here we have 22 minus 14, so here we are going to have 8. Therefore, the chemical formula for T is C4H8. Draw the displayed structure formula of T. So 1, 2, 3, 4. Now, we don't know the name. Now, since we don't know the name, we don't know if it is an alkane or it is an alkene. So how can we tell from the chemical formula that this is an alkane or an alkene? So I'm going to give you some numbers, or I mean chemical formula. So I want you to see this. We have C4, C8, then C4, C10. I want you to see the difference. If this number 4 here, if the number of carbons doubled to give you the number of hydrogen without the remainder, then this substance is an alkene. So must have ENE, because 4 times 2 is 8. Check out for this one. Here we have 4 carbons, but here we have 10. As long as 4 times 2 is 8, as long as there are 2 extra atoms of hydrogen, then this is an alkane. So that's how you can use. So whenever the number doubles to give you the number of atoms of hydrogen, then that is an alkane. So since it's an alkane, make sure you put a double bond between 2 carbon atoms. So with this, the hydrogen will balance 1, 2, 3, 4, 5, 6, 7, 8. So we go to the last question. Would you expect hydrocarbon T to undergo polymerization? Explain your answer. So we'll say yes, because all alkenes can undergo polymerization, and the type of polymerization, if we are to specify, is addition polymerization, and this is due to the presence of a double bond. So as we can see, it's simple. So that's it for this video. Thanks for watching.